10, 9. Ignition sequence start. 6, 5, 4, 3, 2, 1. Liftoff. We have a
The dream flight under microgravity. Microgravity doesn't necessarily occur in outer space only. With human genius and scientific and technological advances, we can finally succeed in simulating a gravity-free environment similar to that of outer space. Japan Aerospace Exploration Agency, or JAXA, is one of the most renowned space technology research institutes in the world. Its primary commitments are training future astronauts, developing satellites, and undertaking research at the International Space Station. This very same institute, every year, also opens a window of opportunity for youth delegates, both from Japan and from Southeast Asian countries, including Thailand, to participate in this project. They are selected by presenting their own research projects in different fields and pitting their scientific wit against one another. Under the project, the Student Zero Gravity Flight Experiment Contest. Each year, the selection committee, consisting of experts in various fields from the National Science and Technology Agency, known as NASDAQ, will scour the country for the most scientifically inclined Thai youth who are strenuously dedicated and committed to their research projects, to present them before the committee in the hope of being selected to experience and participate in this zero-gravity event.
ที่เราอยู่เป็นปกติเขาหน้าสีขาวไม่มีอะไรนะครับแล้วพอที่ขึ้นไปแล้วเนี่ยหน้าเขาเป็นสีแดง
มากโฮโมจีเนียสหมดไม่มีร่างไม่มีอะไรมันก็จะให้ผลดีกว่า
และอะไรที่เราจะได้จากการทดลองในสภาพและน้ำหนักของการฉีดยานะคะสิ่งสำคัญ2 สิ่งอันจะเป็นประโยชน์นะคะ
ได้หลายชิ้นที่ทำงานวิจัยเกี่ยวกับ LD เช่นการสังเคราะห์ด้วยแสง
The selected team is required to design and create real experimental instruments to be used in the weightless environment from pieces of paper where they actually formulated the research project. How can humans create microgravity similar to that of space? We can create a weightless environment by making use of high-performance aircraft. By means of flying parabolic maneuvers, a state of weightlessness or zero gravity can be experienced for a short period of 20 to 25 seconds. Weightlessness, though, starts to occur when the aircraft climbs in an arc and then makes 47-degree angle to the Earth's surface, at which point objects are in the path of free fall. As the aircraft climbs the peak of its arc and turns its nose downward at 47-degree angle to the Earth's surface again. At this split second, occupants in the aircraft can experience a state of zero gravity as though they were in space. In addition, we can experience a state of zero gravity by going on free fall rides. This phenomenon will occur during the first few seconds after the cabins in which we are sitting are dropped. Our bodies will be in free fall as if we were in a state of weightlessness. The same case occurs when we are in an elevator which is allowed to free fall. For conducting research in a state of zero gravity, on an aircraft flying parabolic maneuvers. In each flying round, pilots will fly the aircraft in horizontal circles and in upward and downward curves vertically for 10 rounds on 2 days to create 20 occurrence of zero gravity conditions, by which all youth delegates can conduct the experiments 20 times. Now, we understand how zero gravity occurs, and now our Thai youth delegates are ready for a trip for zero gravity flight research missions in the skies of Nagoya in Japan. Here is the Diamond Air Service Company, where the delegates will make preparations for the experiments before the actual events of zero gravity flight. Zero gravity can be explained as a state of mechanical abnormality. It does not occur on Earth. For instance, on Earth, water always falls from a high place to a low place. However, in a state of bedlessness, this is not always true. So, bearing this in mind, designing experimental instruments carefully and practically is of great importance, or else the hours we put in our experiments will be all in vain. Moreover, working on an aircraft flying in circles, instruments need to be installed safely and firmly to avoid any unforeseen danger. So, for the best learning experience on zero gravity flight, before takeoff, all delegates need to check the experimental instrument whether they are in good state and discuss working procedure in detail with JAXA staff and pilots. Now, it's time to experience a new weightless sensation. Now, the plane climbing to an altitude of meters. Soon, the pilot will fly parabolic maneuvers. As the plane climbs, they will experience double the normal gravity. The body will have a sensation of being compressed and weighed down by double their normal body weight, making them immobile. And when the plane climbs to the peak of the parabola arc, this is the moment that they are waiting for, which means we are entering the long-awaited state of zero gravity. They are having a lot of fun floating freely. But in this moment of joy, the delegates need to get to work on their research projects. Each year, Thai youth delegates usually come up with a number of intriguing research topics for experiment in a state of weightlessness, such as the measure of cholesterol deposits in blood vessels, the movement of algae toward light, and plants' food transportation. There are research projects as interesting as those of Thai delegates from the Japanese and Malaysians, such as cooking rice in zero gravity and experiments on underwater for astronauts.
We're a team from Malaysia, so we developed our experiments called space underwear for the astronauts.
Let's take a look at some of the research projects conducted in zero gravity conditions. The project of these youth delegates was to investigate the movement toward light of algae called Chaetomonas reinhardt. This algae, scientifically called Chaetomonas reinhardt, are green, unicellular, and oval. They move by using two tentacle-like organs called flagella for swimming. In normal conditions, the side of algae will move toward light for food and energy synthesis for growth. What about in the state of zero gravity? How do these algae function? This is what these youth delegates would like to find out. The delegates create experimental instruments under the microscope. They decide a slide in red, the color that this type of algae try to keep a distance from. Then they attach a blue laser to the microscope and fire the laser onto the slide. On the slide, you'll see a blue dot, which attracts this type of algae a great deal, because the wavelength of this light is perfect for the algae's photosynthesis. Now, let's take a look at the result. In normal condition on Earth, this type of algae enthusiastically move toward the light as we can see from the way it clusters around the blue dot. Similarly, in zero-gravity conditions, this type of algae behave the same as it did on Earth. So, if we experiment on this type of algae at the space station, there is a real possibility that it will be able to perform photosynthesis for its growth. On top of that, it can be eaten and used for hydrogen energy production. In the future, it is possible that this type of algae will find its new habitat in space and be used to feed and provide energy for astronauts. In the vast expanse of space, there exists myriad of mysteries waiting for us to solve. Existence in space free of gravity is still considered a huge challenge for humankind. And it depends not only the survival and safety of the astronauts on duty, but also possibly the very survival of humankind in years to come.